Hello everyone, I welcome you all to Startup Academy, India's only exclusive coaching for ISS examination. In the previous lecture, we did numerical analysis. We did one of the formulas of Shepard's operators, in which we studied mu and delta, and we did PYQs based on the operators. In today's lecture, we'll move forward on the same topic, and the topic that we are starting today is numerical integration. Till now, we have been doing numerical differentiation. Now we are starting with numerical integration. What is numerical integration? When we are integrating a function of x, suppose this is from a to b, fx dx, then this is termed as numerical integration, or I, as we denote it. And this is also known as quadrature. What is meant by quadrature? Quadrature means when we have a function when we are integrating a function who's the function of only one variable. Here we are integrating a function who's the function of only one variable x. That means this is, we are doing a quadrature form of integration. If we would have been doing f of x comma y, which is a function of x and y, or f of x y z, which is a function of three variables x, y and z, then these two are not quadratures. These two are not considered as quadrature integration. So this is the formula of our numerical integration. Now in numerical integration, we have some of the rules. We'll do them line wise and with the pyqs. So if the first rule is trapezoidal rule, I will tell you a little bit about how it comes, and you just have to, for the examination it is important that you just have to know the final formula and how to apply it in any function that has been given to us. That's all you want to know. But if we integrate something, like suppose I have a graph, this is x-axis and this is y-axis, and we have a function fx. Okay, so if we integrate fx, then the integration will be in form of slices or bars. These are the form of integrations when we are integrating fx. So these are the form of integration. Integration means by parts. We are dividing the whole range by parts. Suppose we are dividing from a to b. So a range starts from here to b here. So we have divided in three parts, or maybe more than three. So these blocks or bars individually are considered as what? These are considered as trapeziums. As you see that these are trapezium, and hence the name comes trapezoidal rule. Okay, and here fx is always a function of fx is a function of x, which is a straight line. That's why we are drawing lines in here. These lines, why we have drawn, because it is a function of straight line. And that it has also been asked that trapezoidal rules apply when the function is a straight line, a curve, or a 3-degree parabola, whatever. So this is also an important point. Now trapezoidal rule, suppose our initiation is a, from a, we suppose, okay, let us take the integration only. Integration from a to b, fx dx, this is our function. So our initial point is a, and our final point is B. This is our final point and this is our initial point. Suppose we are dividing all of the function in n parts. N parts. So the width here we define it as h. Width will be given by h is nothing but b minus a upon n. Or we can simply say that nh is nothing but equal to b minus a. This is very important relationship that would help us in solving the questions. nh is equals to b minus a. Now, so our formula will be if we have x values of x and values of fx. Suppose values of fx we consider them as y. Okay. So here let us take values of x. One is x naught, then this is x naught plus nh, then this is x naught plus 2nh, x naught plus h, x naught plus 2h, x naught plus 3h, and up till so on xn. Okay, and this is our y naught, then y1, y2, y3, and so on till yn. So our trapezoidal rule is integration from a to b fx dx is equals to h upon 2 bracket y naught plus yn, addition of first and last term, plus 2 into y1 plus y2 plus y3 plus all the terms in between, yn minus 2 plus yn minus 1. This is the formula of our trapezoidal rule. And it is very important formula from our exam point of view. It has the formula directly hasn't been asked, it has been asked in the questions how to solve them. So let us take an example first, then we'll solve pyq. Suppose we have been given an example that we have to solve this integration 0 to 1 x cube dx considering 5 subintervals. That means n is 5 we have been given. So on solution we'll solve it slowly so that you understand the concept. So here a, the initial point here is 0, so a will be 0. The final point here is 1, so b will be equal to 1. N has been given as 5 subintervals, so n will be taken as 5. Now we'll calculate h. We know that h is nothing but b minus a upon n, which is 1 minus 0 upon 5, and which is equals to 0.2. So now we'll make the table of x and fx. Fx here has been given as you can see in the question, it is x cube, which is also considered as y. So let us draw the table. we have to draw 5 subintervals. Okay, so here let us consider x and y. Y is nothing but fx, which is nothing but x cube, as we all know that from the above. So x, we have to divide, we have to start from 0. So 0, and the difference should be 0.2. So it will be 0 plus 0.2, 0 plus 2 into 0.2. That is, here it will be x naught plus h, x naught plus 2h. 2 into 2, 0.2 will be 0.4. X naught plus 3h will be equal to 0.6, and x naught plus 4h will be equal to 0.8. And there should be one more column. We have to get it up till x naught plus 4h, x naught plus 5h. So it will be 0.8 and 1. We have divided, we have taken from the very basic till the very end, and now 0 cube will be 0, 0.2 cube will be 0.008, 0.064, 0.0216, 0.512, and cube of 1 will be 1. So this is our table. Now these are the values, as we all know that this is y naught, y1, y2, y3, y4, and y5. All of these values have been provided to us, or we have drawn that. So now we know that trapezoidal rule is from A to B, fx dx is equals to h upon 2 bracket y naught plus y. Here the nth value is y5, so I'm writing y5 plus 2 into y1 plus y2 plus y3 plus y4. All the values in between first and the last will come here. So here the integration is from 0 to 1 x cube dx equals to h. H was 0.2 upon 2. Then in bracket y naught plus y5. Y naught is 0 and y5 is 1. So we will add 0 plus 1 plus 2 into y1 plus y2, which is 0.008, 0.064, 0.216, and 0.512. 0.008, 0.064, 0.216 plus 0.512. All of this multiplied by 2. So if we cancel this out, we will be getting 0.1, and in the bracket 1 plus 2 into this will become 0.8. You can add that and solve for your own. It will become 0.8. So it will be 0.1, 1 plus 1.6, which is nothing but 0.1 into 2.6, which is nothing equal to 0.26, which is our final answer. That is, integration from 0 to 1 x cube dx should be equal to 0.26 by trapezoidal rule. And since these rules contain what do we say this, since these rules contain errors, so if you in the examination, if you think that I will just solve it by this, I will just solve it by integration from 0 to 1 x cube dx will be nothing but x raised to the power 4 upon 4 with the limits 0 and 1, which is nothing but 1 upon 4 equal to 0.25. And in the option, if the examiner gave you a B, C, and D, which is 0.24, 0.25, 0.26, 0.27. And you tick this one, but this is the wrong answer. Rather, it should be 0.26 because trapezoidal rules and all of these rules contain errors, and hence our answer would differ from the actual integration. And therefore, you shouldn't try these kind of tricks in the exam. In very rare possibilities they might come equal, where there is no error in the trapezoidal rule, but there are rare possibilities of that. Instead, you should just perform the right task that I have provided you with. This is how we solve it in examinations, and the kind of questions that come in your examination, let us solve one of that kind. So this is our question. The value, we have to estimate the value for log 2 obtained by applying trapezoidal rule. So our function has been given from 1 to 2, 1 upon x dx. Now if we integrate this, we know that it is the integration of log of x, and with equal divisions of 1 and 2, with 2 divisions. So n is 2, a is 1, and B is 2. N2, we have been provided with 2 equal divisions of 1 comma 2. That is the limits 1 to 2. Okay. So we have been provided with this. We can find out H. What is the value of H? B minus A upon N, which is 2 minus 1 upon 2, which is nothing but 0.5. Now we'll again make the table of x and y values. And since the divisions are less here and the difference is 0.5, so we will only be having 1, 1.5 and 2. So here we will write x, and here we'll write fx, which is equals to 1 upon x, which is equals to y. So x, first x will be 1, the lower limit, which is x naught. Then the second x will be x naught plus h, which is 1 plus 0.5, which is 1.5. And the second x will be x naught plus 2h, which is 1 plus 1 equals to 2. And these are our limits. Now, if we calculate fx, 1 upon 1 will be 1. 1 upon 1.5 will be 2 by 3. And 2 by 3. And 1 upon 2 will be 1 upon 2 only. Let us write it in fractions. Now we have to calculate the trapezoidal rule, which is integration from 1 to 2, 1 upon x dx is equals to h by 2. H is 0.5 upon 2. Bracket first and last term. This is y0, y1 and y2. First and last term is 1 plus 1 upon 2 plus 2 into the middle term, 2 into 2 by 3. If we solve this, this is 0.5 will be 1 upon 2, and 1 upon 2 into 1 upon 2 will be 1 upon 4. 1 plus 1 upon 2 will be 3 by 2 plus 4 by 3. If we add both of them, we will be getting 1 upon 4 into 9 plus 8, which is 17 upon 6. And 17, 1 upon 4 into 17 upon 6 will be 17 upon 24, which is our option number B. And if you integrate it with the with normality, like we use integration, let us do it that ways also. If we integrate from 1 to 2, 1 upon x dx. Now we know that integration is log of x with 1 to 2. This will be log of 2 minus log of 1. Log of 1 is 0, then the answer will be log of 2 only. And hence, we have to find the value of log of 2. If you remember that, then you can do it, which is a very rare case. So instead, you have to apply trapezoidal rule also only. I have done it slowly just so that you can understand the concept in examination. After practicing many of these kind of questions, you will be able to solve them within 1 minute. Now let's move to a second question. Here again, we have been provided with the trapezoidal rule. We have to solve this in integration from 0 to 10, 2 raised to the power x dx. Your function is 2 raised to the power x, then a is equals to 0, b is equals to 10, and the number of intervals is 10 equal parts they have given. So n is equals to 10. If we solve for h is equals to b minus a upon b minus a upon n, which is nothing but 1 only. Now we'll have to make the table again. Here we need 10 parts. So let us consider this as x and this as fx. Fx, we all know that it is nothing but equal to 2 raised to the power x, which is also considered as y. So we have to start from 0, and with the intervals of 1 we have to reach till 10. So we will do 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and let us say 10 is here. So 2 raised to the power 0 is 1, 2 raised to the power 1 is 1, 2 raised to the power 2 is, let us write it as 4, 2 raised to the power 3 8, 4 is 16, 32, 64, 128, 216, 256, and 512. When x is equals to 10, we can write it as 2 raised to the power 10, which is 1024. I'm writing it here so that you understand, because there is no space, and this is 1. So now the trapezoidal rule from 0 to 10, 2 raised to the power x dx will be h by 2. H is 1 upon 2. A, first one, y 0 plus the last one, 1024. 1 plus 1024, and we have to add all the middle terms, that is 2 into 2 plus 4 plus 8 plus 16 plus 32 plus 64 plus 128 plus 256 plus 512. If we add all of them and then divide by 1 upon 2, then we will be getting our answer 1504.2 something. You can check your answer by adding that. I am directly writing it. The range in which this come, because the minimum range here is 1400 and maximum is 1450. It is greater than 1450, this is wrong, and it is also greater than 1500, this is wrong. So the third would be correct because it lies between 1500 and 1550. 1504 would lie between these range, and the fourth one will also be wrong because 1550 is greater than 1504. So that's it. That's how you solve the question in the answer, in the question examination, and this is how you attempt the trapezoidal rule questions in the examination. If you have any doubt, then you can ask in the comment section or on our WhatsApp channel. Only relevant doubts will be answered, and I hope that this concept is clear. Now you will be able to solve trapezoidal rule questions. Practice as much as you can so that in examination you will not require much of the time for just solving these kind of questions. All the best and thank you.
Startup Academy presents Lakshya 2027, an exclusive batch designed only for serious ISS aspirants.